First of all, Jai Hind everyone. Myself, Dr. Kanika, Assistant Professor in Department of Applied Sciences and Humanities, A.J. Kumar Garg Engineering College, Ghaziabad. Today, I am going to discuss the topic of engineering mathematics. First, and my topic is successive differentiation and nth derivative of some standard functions or some elementary functions. So, I am starting here. Firstly, I am define the what is successive differentiation. So successive differentiation is the differentiation of a function successively to derive its higher order derivatives. If y is equals to fx is a function, then first derivative of y with respect to x will be denoted by dy by dx, or can denote by capital dy and or f dash x or y1. This is called the first derivative of y with respect to x, and here capital D is the equivalent to the d upon dx. Now if we differentiate again dy upon dx with respect to x, then it will be denoted by d2y upon dx square or d2y or f double dash x or y2, and this is called the second derivative of y with respect to x. Now similarly, if we again differentiate the d2y upon dx square, then this is called the third derivative of y with respect to x, and it is denoted by d cube y upon dx cube or d cube y or f triple dash x or y3. And in a similar way, we can find the nth derivative of y with respect to x, which can be denoted by d n y upon dxn or d n y or f nx or yn. Now this table denotes the notations of differentiation: first derivative, second derivative, third derivative, and up to nth derivative. So first derivative of y can be denoted by y1 or f dash x or dy by dx or dy, and in a similar way nth derivative of y with respect to n can be denoted by yn or fnx or dny upon dxn or dny. Now we will find the nth derivative of some standard function. First standard function is ax plus b power m. Firstly, we will assume this function is equals to y. Now we will differentiate y with respect to x. So first derivative of y will be denoted by y1. y1 is equals to, and differentiation of this function with respect to x will be ma ax plus b power m minus 1. Now again differentiate y1 with respect to x, then it will be y2 is equals to m minus 1 a square ax plus b power m minus 2. And in a similar way, we can find the nth derivative of y with respect to x, because here is a sequence. Here in y1 ax plus b power m minus 1, and in y2 power is m minus 2. So in yn power will be m minus n. Now for a, in y1 a power 1, in y2 a power 2, so on. In yn here will be a power n. Now in y1 here is m, one term, in y2 is two term m minus 1. So in yn here will be n terms m minus 1, m minus 2 up to m minus n minus 1. So now here raises some cases. First case is m is positive integer. If m is positive integer, then we can combine this function as a factorial function. So to make this terms as factorial, we have to multiply some terms. So we will multiply these terms and divide by these terms to yn, and this is as it is given. Now yn is equals to, here these terms is equals to factorial m. So this is equals to factorial m, and this is equals to factorial m minus 1, and a power n ax plus b power m minus 1. So this is the nth derivative of ax plus b power m if m is positive integer. Now next, for case second, if m is equals to n and m is positive integer, so now we will put m is equals to n in this nth derivative. So m is equals to n, here will be yn is equals to factorial n upon factorial 0 a power n ax plus b power 0. So we also we know that factorial 0 is equals to 1 and power of any number and 0 power of any number is equals to 1. So this is equals to factorial n a power n. Now third case, if m is equals to minus 1. So our function will be y is equals to x b power minus 1. So is equals to, we can write 1 upon ax plus b. Now we will put m is equals to minus 1 in this nth derivative of function. So put m is equals to minus 1. So here will be minus 1, a minus 2, minus 3 and up to minus n into a power n ax plus b power minus 1 minus n. So this is equals to minus 1 power n into factorial n, and a power n upon ax plus b power n plus 1. Now second function is y is equals to log ax plus b. Now first we will differentiate y with respect to x. So first differentiation of y with respect to x is equals to y1. So y1 is equals to a upon ax plus b, because differentiation of log x is equals to 1 upon x. So differentiation of log ax plus b is equals to 1 up a upon ax plus b. We can write in this form, and here we know that factorial 0 value is equals to 1. So we can write here factorial 0. Now we again differentiate y1 with respect to x. So y2 is equals to minus a square upon x plus b whole square, and we know that factorial 1 is equals to 1. So we can write here factorial 1. Now again differentiate y2 with respect to x. So we will get y3 is equals to 2a cube upon x plus b power 3. And we know that factorial 2 is equals to 2. So we can write here factorial 2. Now again differentiate y3 with respect to x. So we will get y4. So y4 is equals to minus a power 4 2 into 3 upon ax plus b power 4 is equals to minus 1 power 3 into a power 4, and we know that factorial 3 is equals to 3 into 2 into 1. So we can write 2 into 3 as factorial 3 and upon x plus b power 4, and so on. We can write nth derivative of y with respect to x. So yn is equals to minus 1 power n minus 1, because in y1 here odd terms are negative, even terms are negative, y2 is negative, y4 is negative, and odd terms are positive. So we will write minus 1 power n minus 1 because if we put here odd number, then we will get positive, and if we will put here even number, then we will get negative 1. So now a power in y1, a power 1, in y2 a power 2, in y3 a power 3, in y4 a power 4, so on. In yn here will be a power n. Now next term, in y1 factorial 0, in y2 factorial 1, in y3 factorial 2, so on. In yn here will be factorial n minus 1. Now for ax plus b powers, 4y1 power 1, 4y2 power 2, 4y3 power 3, 4y4 power 4, so on. For yn here will be power n. So nth derivative of log ax plus b is equals to this. Now if we put a is equals to 1 or b is equals to 0, then we can get a derivative of log x, so which is equals to minus 1 power n minus 1 factorial n minus 1 upon x power n. Now next, exponential function. Now we will find the nth derivative of exponential function as y is equals to a power mx. So first we will differentiate y with respect to x. So we will get y1 is equals to m a power mx log a. Now again differentiate y1 with respect to x. We will get y2 is equals to m square a power mx log e base a power square. So on, we can get yn because in y1 here m power 1, in y2 m power 2, so in yn here will be m power n, and a power x, a power mx is common, so we will write a power mx. Now here in y1 log a power 1, in y2 log a power 2, so on. In yn here will be log a power n. Now similarly we can find the y is equals to e, any derivative of y is equals to e power mx, or we can put in this derivative a is equals to e. Then we can see that here yn is equals to m power n e power mx. Now next, here is the example of nth derivative. This function is given, and this function, firstly we will assume this function equals to y, and we can see that this function is not a standard function. So firstly we will convert this function as a standard function. Standard function means ax plus b power m, ax plus b power minus 1, or a power mx form, or e power mx form, which in standard functions nth derivative we have already find. Firstly we will find the roots of this quadratic equation, so it will be 2x minus 1 and 3x minus 1. Now here the multiplication of two roots. Now we will apply here the partial fraction rule. So partial fraction rule, a upon 2x minus 1 first factor plus b upon 3x minus 1 second factor. Now we will take LCM, so 2x minus 1, 3x minus 1, and here in numerator a into 3x minus 1 plus b into 2x minus 1. So now this will be cancelled out. Now here 1 is equals to this. Now to find the value of a and b, we will put firstly this term is equals to 0. So if this term is equals to 0, then x is equals to 1 upon 3. So we will put firstly x is equals to 1 upon 3, and we will get b is equals to minus 3. Now again put second term 2x minus 1 is equals to 0, then we will get a is equals to 2. So put the value of a and b in this form, partial fraction form. So put these values 2 and value of b is minus 3. So now this is our function, and this is in standard form. So we can apply the formula of nth derivative of ax plus b power minus 1, and we know that the nth derivative of ax plus b power minus 1 is equals to minus 1 power n factorial n ax plus b power minus n minus 1 into a power n. So to find the nth derivative of this term, here 2 is constant, so it will be as it is, and nth derivative of 2x minus 1 power minus 1 is equals to 2 power n minus 1 power n factorial n 2x minus 1 power minus n minus 1. We got this when we put here a is equals to 2 and b is equals to minus 1. So we will choose this value according to this. Compare 2x minus 1 by ax plus b. So 2x minus 1 is equals to ax plus b. So now by comparison, a is equals to 2 and b is equals to minus 1. Now again, now we will find the nth derivative of this function. Here this is constant term, so it will be as it is. Now nth derivative of 3x minus 1 power minus 1 will get, to put the value of a is equals to 3 and value of b is equals to minus 1 in this nth derivative. So it will be minus 3 into 3 power n minus 1 power n factorial n 3x minus 1 power minus n minus 1. Now here minus 1 power n factorial n is common, so this is equals and this is we will get. Now next example, we have to find the nth derivative of this function log ax plus x square. This is not in the standard in the form of standard function. Now firstly we will convert this into the standard functions. So here we can see that here x is common, so we will take x is common and remaining term is a plus x. Now we will apply the logarithmic property, log a b is equals to log a plus log b. So here will be log x plus a. Now differentiating this term n times, so here y is equals to this. So nth derivative of y is equals to yn, and now we will find these nth derivatives. So we already know that nth derivative of log ax plus b is equals to minus 1 power n minus 1 factorial n minus 1 a power n upon ax plus b power n. Now to find the nth derivative of log x, we will compare x by ax plus b. So we have to put a is equals to 1, b is equals to 0 in this formula. So we will get this minus 1 power n minus 1 factorial n minus 1 power n upon x power n. Now we will find the nth differentiation of log x plus a. So to find the differentiation of this term, we have to put a is equals to 1 and b is equals to a in this formula. So we will get this term. Now here in these two terms, we have common terms minus 1 power n minus 1 factorial n minus 1, and remaining terms are these. So this is the nth derivative of log ax plus x square. Now similarly we can find the nth derivative of this function. Firstly we will convert this function in a standard form, and to write in a standard form, firstly we will apply the logarithmic property log a upon b, which is equals to log a minus log b. So log a minus log b. Now this is not in the standard form. So to convert this function y into the standard form, we have no idea. So now we will differentiate this with respect to x. So y1 is equals to differentiation of these terms. This is first function, this is second function. First function, this is first function, or this is second function. So first function as it is, and differentiation of second function, differentiation of x is 1. And now second function as it is, and differentiation of first function, derivative of log x minus 1 is equal to 1 upon x minus 1, and derivative of log x plus 1 is equal to 1 upon x plus 1. Now we will multiply x in these two terms, then we will get x upon x minus 1 and minus x upon x plus 1. Now here this is in standard form, this is in standard form, but this is not in standard form, and this is also not in standard form. So to convert these two terms in standard form, we can write this term as this 1 plus 1 upon x minus 1, and minus x upon x plus 1, we can write this term as minus 1 plus 1 upon x plus 1. So now here 1 will be cancelled out by minus 1, and now we have these terms, and all terms are in standard form. So we already know that nth derivative of log ax plus b and nth derivative of 1 upon x plus b. So these two nth derivatives we will apply here. But this is not y, this is y1, and we have to find yn, nth derivative. So to find the nth derivative, we will differentiate y1 and minus 1 times. So we will get yn. So n minus 1 is derivative of these terms. Now we already knows these formulas, nth derivative of log ax plus b and nth derivative of 1 upon x plus b. Now we will find the n minus 1 times differentiation of log x minus 1. We knows this formula. So we will put here a is equals to 1 and b is equals to minus 1, and n is replaced by n minus 1. Then we will get this, and similarly we will get this. And now here we have common terms. Which common terms? Minus 1 power n minus 2. Here, and here. So here will be remaining terms are here minus 1, and here factor n minus 2, here factorial n minus 1, or we know that factorial minus 1 is equals to n minus 1 factorial minus 2, and here factorial minus 1 is equals to n minus 1 into factorial minus 2. Now we will take common factorial minus 2 and these remaining terms. So this is the nth derivative of the given function. Now we will find the nth derivative of sine ax plus b. So if firstly we will put this function as equals to y. Now differentiate y with respect to x, then we will get y1 is equals to differentiation of sine ax plus b is equals to a cos ax plus b. Now given function is in sine form and y1 is in cos form. So to find the sequence, we will convert this cos term in a sine form. So we can write this as a sine pi by 2 plus ax plus b. Now we will again differentiate y1 with respect to x, then we will get y2 is equals to a square cos ax plus b, differentiation of sine a square sine ax plus b, and here will be minus sine. So is equals to a square and 2 remove the minus sign, we will write this in this form, sine 2 pi by 2 plus ax plus b, and so on. And in a similar way we can find the nth derivative. Here in y1 a power 1, in y2 a power 2, so in yn here will be a power n. Now in y1 sine pi by 2 plus ax plus b, and in y2 sine 2 pi by 2, and in y3 here will be 3 pi by 2, and in y4 4 pi by 2. So in general way in yn here will be n pi by 2 and plus ax plus b. Now to find the nth derivative of sin x, we will put a is equals to 1, b is equals to 0 in this formula, so we will get this nth derivative. Now next, y is equals to cos ax plus b, so we will find this in a similar way. You find y1 and y2 and y3 and convert it into the cos form, because our function is in cos form, cos ax plus b. So we will get this nth derivative, as we have already find the sin x plus b. Now we have to find the nth derivative of this function sin 6x cos 4x. This function is in sine or cos form but not in a standard form. Here is the multiplication of two functions. So now let y is equals to sin 6x cos 4x. Firstly we have assumed this function is equals to y. Now we know that sin 2 sin a cos b is equals to sin a plus b and plus sin a minus b. So we will apply this formula here. So firstly we will multiply and divide by 2. So 2 sin 6x cos 4x is equals to sin 10x plus sin 2x. Now we will find the nth derivative of this term and nth derivative of this term by using the formula. Nth derivative of sin ax plus b is equals to, we have already find this nth derivative, a power n sin and pi by 2 plus ax and plus b. So we will put a is equals to 10, b is equals to 0, then put in this formula, then we will get this. And now put a is equals to 2 and b is equals to 0, then we will get this nth derivative. So now next, now we have to find the nth derivative of sin square x cos cube x. So now let this function is equals to y. Now this is not in standard form. Here is the powers of sine or cos and multiplication of sine cos. So firstly we will convert this function in a standard form. So sin square x, we can write cos cube x as cos square x into cos x, and we know that 2 sin a cos a is equals to sin 2a, right? Now firstly we will multiply by 4 and divide by 4. So 4 sin square x cos square x is equals to sin square 2x and into cos x is equals to, now we know that sin square 2x is equals to 1 by 2 1 minus cos 4x. So so put this value here, so it will be 1 upon 8 1 minus cos 4x into cos x. Now multiply by cos x in this bracket, so we will get this. Now here this is not in standard form, this is in standard form but this is not. Now to convert this term in standard form, we will apply this formula, cos a cos b is equals to 1 by 2 cos a plus b plus cos a minus b. Here a is 4x and b is x, so we will get these terms. Now all three terms are in standard form. Now we will apply the nth derivative of cos ax plus b. We know that already. a power n and cos n pi by 2 and plus ax plus b, right? Now we will apply the formula and get these nth derivatives. Now next we have to find nth derivative of sine 4x. Now let this function is equals to y is equals to sine square x and square. We can write this function in this form, and now we knows that 2 sine square x is equals to 1 minus cos 2x. Now firstly we will multiply and divide by 2 and put this value here. So here will be 1 minus cos 2x and whole square. Now we will open this whole square and apply a minus b whole square is equals to a square minus b square, a square plus b square and minus 2ab. Now a is 1 and b is cos 2x. So we will get these terms, and now this is in standard form and this is also in standard form, but this is not. Now to convert it into the standard form, we will apply the formula 2 cos square x is equals to 1 plus cos 2x. So here cos 2x, so here will be cos 4x. Okay, 1 by 2, 1 plus cos 4x. So is equals to 3 by 8 minus 1 by 2 cos 2x plus 1 by 8 cos 4x, and now all three are in standard form. So we will apply the nth derivative of standard function. So here and derivative of constant term is 0, we know that. So here the derivative of this term will be 0 and derivative of cos 2x will be equals to this by apply the formula of nth derivative of cos x plus b, and now here will be this. Now we can find the nth derivative of any of the function. So these are the nth derivative of function y is equals to sine ax plus cos ax, and we have to prove this nth derivative is equals to this. This is already in standard form, so y is equals to sine ax plus cos ax, and nth derivative will be equals to this by apply the nth derivative of sine ax plus b and nth derivative of cos ax plus b. Now we have to prove in this form, so we will take square and root of this term. So firstly we will expand the whole square, so a square plus b square plus 2ab, and we know that sine square a plus cos square a is equals to 1 and 2 sine a cos a is equals to sine 2a. Now we will apply the formula of sine a plus b, which is equals to sine a cos b and plus cos a sine b. So here will be sine 2x cos n pi plus cos 2x sine n pi, and we know that cos n pi is equals to minus 1 power n and sine n pi is equals to 0. So we have proved this nth derivative. Now these are some references of books, and now thank you.